Okay, now part B. Prove that there exist real numbers D, E, F, G for which all balancing pairs S and T satisfy an equation of the form blah 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 and determine the values of D, E, F, G. Alright, so basically we're still talking about balancing pairs. The four parts still have the same area, and now we have such a relationship, and we have four coefficients D, E, F, G, and we are supposed to find all of them, and that's it. Okay, let's have a look. Now here, S is no longer SC. Okay, that's separate points, and the four pieces they have the same area, and since the total area, I mean the total area of triangle ABC is half base is 2 times height is 4, and it is 4 in total. So each piece would be 1. And since they have the same area, each one is a fourth of the total. That basically means triangle XTS is 1. All right. And this quadrilateral PXTA is 1. But obviously this quadrilateral is quite an ugly one, and there's nothing we can do about it. I mean, we cannot express its area, although we know that it is 1. So we have to check the fact that it is actually part of the bigger triangle PAS, all right? Because the quadrilateral plus XTS here is exactly PAS, and PAS should have the area of 1 plus 1, which is 2. Okay, so a triangle is always easier to deal with compared with such a quadrilateral, which we can basically do nothing about. And this one, for the same reason, this is 1, and we consider the whole thing. We consider the whole of a QAC, and QAC should be again the quadrilateral plus the 1 down here, XTX 1 plus 1, that is another 2. Okay, and now we have the top quadrilateral, which is a PBQX. It is 1 as well, but in fact we do not have to look at it. We don't even need to care about it. That is because provided this equation is 2, and this equation is 2, and this equation is 2, it immediately follows that the area of this quadrilateral has to be 1. That is because this is 1, 1, 1, right? These two equations basically mean that this quadrilateral is 1, and the bottom piece, triangle piece, is 1. And these two quadrilaterals basically means that this is 1 and this is 1. And since the total is 4, so the top piece has to be 4 minus 1 minus 1 minus 1, which is 1. So it is quite natural. It just follows this. So as long as these are true, we do not actually have to look at the top piece. So just leave it out. Okay, now all we have to do is take good care of the three equations here. They all have to do with triangles, and they have a base and they have a height, and that's where we can derive the kind of a relationship. Okay, so let's check the first triangle, XTS, the bottom one. It is a base, and a base is S plus T, all right? It's not S minus T, okay? S plus T, because please keep in mind, T itself is already set as a negative value. So T itself is set as a positive value. The x-coordinate of point T is negative T. So the length of TS is actually S plus T. Okay. And it follows that the height should be 2 over S plus T, because the formula is half a base times height. So height is, the total area is 1. So it follows that the height has to be 2 over S plus T. Okay. And the height is nothing but the y coordinate of point X, right? It's actually just height would be, this is I will write yx. Okay, the x is a uppercase X. This is the point, and the point has a y coordinate. How high is it? It is at the height of yx. Okay, it is just 2 over S plus T, and because this is the height of the triangle. Okay, and now move on to this triangle. Of course, we are looking for this one, yp, okay, the y coordinate, the height of p, which is also the height of this triangle. So let's start from the base. The base would be the length of AS. It is 1 plus S, all right. 1 plus S, and since the total area is 2, so it's 4 over 1 plus S, which is YP. We found it, okay. Now, the third one, QAC here. Of course, we are looking for a YQ. Okay, let's just put it down here. Okay, YQ. And what's the base again? A QAC, it's a TC. TC is a T. This part is T, all right? And a positive value, T, and this is 1. So it is TO plus OC, okay? This is a 1 plus T. And it follows that the height is 4 divided by 1 plus T. And this is a YQ. Okay, here we go. Now what? I would ask you to check, we'll check it together. Okay, let's examine this structure here. I mean, the P, say this is a P, right? And this is a T, maybe a little bit over, but it's not that important. I just want to show you that the structure actually matters a lot. Okay, this is X. Now we have a structure like this. This is a S, and this is a, okay, this is the foot. This is the foot of the altitude. And now we have the height here, YP. This is a YP, right? This is a YX. We have this as well. And we have a YQ. Okay, this one. And now see, in this structure, we have this part. This is kind of an A shape, lay down A shape, okay? And on the other side, we have another A shape. And within these kind of A shapes, we have two similar triangles. We have similarity, right? And we can use similarity to do something. For example, now we have this and this, right? This is YP and this is YX. So here's a ratio of similarity. And this should be the total length of this to the total length of the of this shorter part, right? And it has to do with X coordinates, right? For the same reason, we have a YX and we have this YQ. So we can find the ratio of similarity of these two triangles, and it is just this short part to the longer part. Again, it has to do with X coordinates, right? And okay, please notice that since we know everything about this line AB, so we have two given dots here, we have two given points here, so we can tell actually the equation of AP. Okay, I can just tell right now it is because the slope is 4x, y-intercept is 4x plus 4, okay? And how about this one? This is a negative 4x plus 4, okay? It's just a 1 second thing. And after that, based on these equations, once we know YP, we can actually tell XP. XP is already known, kind of already known. And for the, similarly, XQ is already known, all right? If XP is already known, okay? And of course, I mean, XS, that coordinate, X coordinate of S is already known. It is just S, okay? It's defined as S. So this distance, the length between this foot and the S is kind of known. We can express it in terms of S and T. So the longer, the length of the longer segment is already known, okay? And for the reason, the length of this longer segment is already known, all right? And we have the ratio of similarity, so we can tell the length of this short segment. For the same reason, the length of this short segment, all right? So it is known, and it is known. Meaning, okay, let's go back to this this comprehensive structure, meaning this part is known, right? This part is known, and this part is known. And if this part, both parts are known, I'm sorry, I mean, this part is known, okay? The length of this part is known, and the length of this part is known. And if you put these two parts together, it is none other than the difference between S and the T, right? It's just the lowercase s plus lowercase t. Hence, we have got a equation. Okay, we know nothing actually about x because x is not lying on any known line, right? TQ is not yet known. SP is not yet known. Or if you want to express them, you might, I don't know, you might be getting involved into something quite complex. So I didn't do this. But obviously, X is a kind of a common point. So everything has to be developed on both sides of it. Now we have this and we have this. We just have to put them together, and we now return to a relatively easier, simpler expression, which is S plus T, okay? And then we can try to simplify what we have got. Maybe we can derive something like that. Okay, that is the plan, all right? All right, we planned everything, and now let's just carry out the plan step by step. It might take some time, so, but we already know what we're gonna do. Okay, we have these kind of structures over here. Now I have to move on to another sheet of paper, but don't worry. Let me just, okay, I can do this. Okay, now I will, okay, no, okay, here, this is better. Okay, now I have to calculate XP and YP first. Sorry, XP and XQ first, all right? So XP is lying, P is lying on this line, right? Y is 4x plus 4. And in other words, I mean, X is Y minus 4 divided by, Y minus 4 divided by 4, right? And this one, how about this one? In other words, X is negative 4, it is, no, sorry, it is positive 4 minus Y and divided by 4. Okay, so let's plug them in. If for XP, it is YP minus 4 divided by 4, okay? It is actually YP, yes, okay, YP minus 4 divided by 4. And this is actually, okay, we need a bit calculation here on this piece of paper. YP minus 4 divided by 4, it is just YP divided by 4 minus 1. What is YP? YP is this, 4 divided by 1 over S. So it is 1 over S minus 1. In other words, it is, okay, we just leave it here because I don't want to simplify it right now. Later, maybe we can just simplify everything in one go. So I just leave it here. Okay, how about XQ? XQ should be, okay, let's plug this in. 4 minus YQ, right? Divided by 4. And this is a 4 minus YQ divided by 4. 1 minus YQ divided by 4. And it is 1, YQ, what is YQ? YQ, here we go. Okay, 1 minus 1 over 1 plus T, okay. It is 1 minus 1 over 1 plus T, okay. Now we've got XP and XQ, okay. Now let's again have a look at this, this structure here, okay. We can see everything and refer back to then whenever we need. We have the data here, okay. So let's check. Let's consider this this part first. Okay, this part first. I'll put the letters on. This is a P. Okay, this is X. This is S. Okay. So what's the ratio of similarity? On one hand, the ratio of similarity should be YX to YP. On the other hand, the ratio of similarity is this part is XS minus XX. Okay. This one actually is a lowercase x, okay? This one is a uppercase x. This is the point, and this is the x coordinate. And on the bottom, it is x and a p, all right? It is xs minus, wait a second, xp. Okay. Now, we have to plug something in, what is yx? Yx is, here we go, this is yx, okay? 2 over S plus T. What is YP? YP is, come on, this one, okay. 4 over 1 plus S, right? YX, YP here, okay. Now, on the other hand, we've got XS. What is XS? Easily S. XX, we do not know, but let's define this as a, let's say, XX, let's define it as a, let's just call it on, denote it, just we just use X, okay? So X stands for XX. So let's say X. And on the bottom, x minus, okay, finally, xp. This is what we took pain to look for. This one, okay, this one, just let's use a bracket. Okay, maybe I should have simplified it, but never mind, it doesn't make much difference. Okay, this is the thing, this is the thing. And let's simplify it a little bit. On top, it is a s plus 1. On the bottom, it is 2 and s plus t. And on the other side, it is x minus x. And this is a s plus 1 minus 1 plus s. Okay, this one. And, okay, diagonal, it is 2s times t. S minus x is s plus 1 square minus 1. Okay, and let's open up the bracket and see what happens here. So 2s plus t and s minus x is s square plus 2s. All right, and then move it over. We have that s minus x is s square plus 2s over 2 times s plus t. Okay, that's quite something, but let's just move on from here. And x should be s minus 2 s plus t under the bar. On top of the bar, we've got, above the bar, we have okay, s squared plus 2s. Okay, this is the first expression we've got for x. Okay, x is x, the x coordinate of this point, x. And this is just one of the two possible expressions. That is because we have got two structures here. We've just used the part of it, one of it. Okay, now let's use the other one. I guess we need another sheet of paper. Basically the same thing, but not exactly the same. You cannot just substitute s with a p or s with a t, okay? Because t is, I mean, the point t is on the other side, so it's a negative p. It's a negative t thing. Okay, so still be careful. Let's just do it step by step. And it's t here. It is x here. Okay, it is q here, and we have got the ratio of similarity again. Yx. I mean, it's a y. It's a height. Yx over yq. And yq, okay? And on the other hand, we've got this one. Okay, be careful. What's this one? This is xx, okay, minus xt, okay? And on the bottom, we've got xq. This is xq minus xt. xq minus xt, okay? As long as we do minus, we won't make any mistake. We don't have to worry about anything. It's a minus. It's just the distance between the two points. Distance between two foot. And this one has this one is on the right, so it has a larger x coordinate, and that's it. So there's nothing to worry about. And let's plug something in. Yx again. Yx, come on, 2 over s over t, s plus t. Okay. On the bottom, yq. Oh, here we go. S 1 plus t. Okay. On the other hand, we've got this again. Okay, this is x, and this is okay, minus xt. Be careful. Minus xt. What is xt? Xt is negative t. Minus xt is plus t. Okay, that makes sense, right? Plus t. You add the length of this part onto. Okay, so it is x plus t, and this is xq. What is xq? Okay, again, this one. 1 minus 1 over 1 plus t. Okay. 1 minus 1 over 1 plus t. Did I copy right? Yes, it is. Okay. xt. Oh, come on. It is xq minus xt. Minus xt. What is xt? Okay, easily. It is a plus t. Because xt is it is a minus t. So minus it is plus. Okay. Okay, now it seems that we will need to simplify them again. Okay, just do not complain. Okay, x plus t, and on the bottom it is 1 t plus 1 or 1 plus t. It doesn't make a difference. It is 1 plus t. Okay, and diagonal, it is 1 plus t square minus 1. It is x plus t times 2, okay, s plus t, okay. So this one is, okay, I'll just do it quickly. X plus t is t squared plus 2t over 2 times s plus t, okay. So it follows that x is t squared plus 2t over 2s plus t minus t. Okay, this is x again. So when using this structure, we derive this equation, the expression for x. And using the other structure, we derive another expression for x. Okay, compare. Quite similar, right? But not the same. And if we kind of build a bridge between them, then we have got a, it's not an equation. Yes, it is it. It is an equation, but we're not going to solve the equation just that. Okay, let's see what the equation looks like. What does the equation look like? I mean, t squared plus 2, okay, let's go here. T squared plus 2t over 2 bracket 2s plus t minus t. Okay, I'm just copying this over here. This is x, right? And on the other hand, it is, now I'm copying this part. S minus s squared plus 2s over 2 bracket s plus t bracket, closing bracket. Okay, now we have to deal with this, and it is already quite close to what we want, right? It is quite close. We just hope that it is not identity. Otherwise, okay, everything is in vain. But it won't. It's not true. So move it over. Let's see. 2s plus t. On top, it is okay, t squared plus s squared plus 2t plus 2s. On the other side, we've got s plus t. And then move it over, we've got t squared plus s squared plus 2t plus 2s is 2s plus t squared, okay. And we've got actually t squared, okay, let's do it slowly. And s is a 2s squared plus 2t squared plus 4st is 4st. And these can be removed and these can be reduced. So on the right side, let's just write s squared plus t squared. On the left side, let's write 2t plus 2s minus 4st. Okay, this is what we have got so far. And what we want is this, okay? S squared plus t squared is something st. Come on, this is something st. Something is -4. D is -4. Plus something s. Okay, E is 2. Something t. Okay, F is 2. And something, there's nothing. So G is 0. So let's just write them down. Here. Can I? Okay, I just write it here. So D, E, F, G, are, what is D again? Okay, something st. -4. What is E? 2, and finally, constant. There's no constant, 0. Respectively. Okay, this is the answer to B, and this is the solution, like 3 pages. Basically, this structure could be important, and these kind of geometry things. And after that, it comes to some the building some equation, and finally we reach this. We end up with this, which is a good result. Okay, and that's all for it. And later, we'll move on to a subproblem C, which is supposed to be the hardest problem, the closing one of the test.